making them with energy use. I mean, more efficiency energy consumption can be used in this way. Pollution control and environmental monitoring by the production of sensors and methods for the treatment of pollutants in the environment, and in conclusion, these points lead to economy, circular economy initiatives. I mean, we would try to produce things that make us leave the principle of take, make, and dispose, but rather than this circulate, reuse the material. I will start with the examples which I will talk about: corrosion, metal corrosion, catalysis, and water treatment. Corrosion, as you know, corrosion simply is defined as the degradation of metal. Metals are everywhere, even in industry or even in medical devices, in energy production stations, everywhere. Metals are everywhere, and all of us have an idea about the corrosion, the problem of corrosion, and how it is serious. It causes degradation of the metal, leading to structural failure, economic cost, environmental damage, and operational downtime. So, what chemists can do in this field? We can produce, our chemists already working on this field, produce materials that are used to protect metals from corrosion. We can stop corrosion either by treating metals or by coating metals and protect them from the environment, or sometimes when we need to clean up pipelines, oil pipelines, or power stations, or whatever the metal we need to use to clean it or descale it. Sometimes we use aggressive solutions. So, in this case, to prevent the damage, or to prevent the occurrence of corrosion, we introduce materials for this purpose. And I will show some examples of the production of corrosion inhibitors, and I will show you some chemistry where most of the engineers don't know how corrosion inhibitors work, but they take it to the application. Here's the science behind some corrosion inhibitors. If you see these molecules, this is not a random synthesis, or just choose any chemicals or any structures to be used as corrosion inhibitors. But we design the molecules on the structure on the molecular level, and choose the atoms which involved in such molecules to get them absorbed on the metal surface, and then they can protect the metal from corrosion. These are two examples, just two examples from our work, in which we have used such molecules, organic molecules, as corrosion inhibitors. In this work specifically, we can consider them as eco-friendly corrosion inhibitors because we managed to get a very high inhibition efficiency, up to 95%, by a very low concentration, something like 0.01 millimolar. And this is very good in terms of green chemistry. And we have proved the efficiency of our materials by electrochemical studies, which shows how, because it is an electrochemical reaction, so we study the details of the electrochemical reaction and see how it works. And these are very interesting results which show the efficiency of our corrosion inhibitors. Rather than we do surface analysis, you can see the difference between corroded and protected surfaces when we treat them with organic molecules. And this is the science behind the mechanism of action of such inhibitors. If you see, we can determine how the atoms get attached to the surface. But the point is, when we move to the application, here we need to collaborate with engineers. We have this work. We have proven in the lab these compounds, which are considered as free corrosion inhibitors. We have proven this in the lab. They are working perfectly. Another type of corrosion inhibitors, we have used nanomaterials. One of them is the selenium. The selenium, which is an eco-friendly, it is used as supplement. It has a very, very, very interesting applications in pharmaceutical chemistry. It is used as antibacterial agent, so it is safe material. We have thought about the use of such eco-friendly material as corrosion inhibitor. The green chemistry involved in this work, we have even synthesized these eco-friendly particles by eco-friendly process. We have used eco-friendly producing agents, eco-friendly materials. We have used ascorbic acid, which is vitamin C, to get the nanoparticle synthesized. But the problem facing, I'm not sure if somebody here worked with the nanochemistry. One of the problems of the nanomaterials is the aggregation of nanomaterials, and then they turn to micro particles, and then they lose their large surface area and they lose their activity. So we have to stabilize them. In this work, we have used eco-friendly, again, eco-friendly stabilizing agents, which are polymers, which is ketosan and PVA, to get these nanomaterials stabilized and effective. So the shelf life, even in the lab, again in the lab, we have left the solution for months. It is still stable and still give a very good activity as corrosion inhibitor. So here, this is a diagram shows how we have managed to get the selenium nanoparticles synthesized by green method and by using surface analysis, electrochemistry, gravimetric analysis to prove that our materials are working properly and in high efficiency. In other words, we have changed it. As I said, we are using another polymer, which is ketosan, as a natural friendly polymer, and even it enhances the efficiency of corrosion. It can be used for when it is disposed. We need to clean mechanical metallic parts, the drainage or the waste will be drained. This material is safe for environment. It even gives a good antibacterial activity. So it is safe in all means, safe and efficient in all means. So the sustainability advantages of corrosion inhibitors can be summarized in these few points. They are eco-friendly materials, high efficiency at low concentrations, prolonged material lifespan, reduces environmental impact. They are compatible with industrial applications. This is the most important point. Theoretical and experimental optimization have already been done in our labs, or I mean, for every published paper on this work. A promotion of circular economy principles. Another topic is I'm going to talk about briefly is the use of catalysts. Sorry. Okay. Is the use of catalysts. Catalysts are materials which are used to make the chemical processes, the synthesis of a new material, make it perfect, easy, and in reusable, using reusable materials. I will go through this. Okay. So one of the materials which we have developed and used as catalyst for the synthesis of organic molecules, which is again can be implemented in industry, is the use of clay. Clay is a good source for such eco-friendly materials. Here I will show you some of the reactions. This reaction, for example, for the production of this kind of compounds, these are just, I mean, a substrate to show how these materials can be used as catalysts. This kind of organic molecules may be needed to produce in industrial field, in chemical engineering field, in the pharmaceutical chemistry, whatever. For such reactions, to get such a product, we need two steps. For example, this reaction, in two steps, we need to use heaters for refluxing for several hours. We need to use solvents. We need to use acids. And again, we move to another step to do the same in the next step. And all of that, time consuming, energy consuming, and wasting of hazardous materials. But we can eliminate all of that by using this catalyst. Many catalysts are already reported. In our case, we have developed the clay. One of the studies, we have treated the clay, a special type of clay. I mean, not any type of clay. A special type of clay is the MTK10, We have just treated it with acid and then used it in the synthesis of such organic molecules. If you see the important, here we know the science behind how the catalysts work. This is the mechanism. I know you are not interested in such details, but I have to show. But the most important thing is the number of cycles. As I said, we have eliminated the use of solvents. We have eliminated the use of energy or the consumption of energy. We have saved time by using this material, which is recyclable material. Up to 5 cycles, it gives its efficiency. So by eliminating all of that, using the clay, we can produce chemicals in an efficient way. Another one, we have used the clay as a composite with certain types of nanomaterials. And in this research, we managed not just keeping the activity of the clay, but also enhancing the productivity. If you see about 95 conversion, chemists doing what I'm talking about. The product here up to, I mean, this is in terms of a green chemistry and the atom economy. That is a conversion of all of the chemicals are used in the desired products, and we avoid side products. So again, sustainability advantages of the use of catalysts. They are environmentally friendly methodologies, solvent-free conditions. The use of natural catalysts, as I said, we are using the clay recycling of catalysts, microwave assisted. This is the point where we avoid the energy consumption. And instead of running heaters for 10 hours or even overnight, we can do it within a minute using microwave reactors. The most important thing is the broad applicability in industrial chemistry. And finally, the use of polymers for water treatment purposes. There are a huge number of papers published by Iraqi researchers about this topic, but there is no engagement for the sustainability with this work. The problem, I will show you the message. This is an example. We are using just natural polymer, okay, ketosane again, this kind of compound by a single reaction, and the use involvement of, again, eco-friendly material, which is the titanium oxide nanoparticles. We managed to reduce 2 kinds of pigments from water solution. So if you see the concentration of the contaminants, of the organic contaminants, which are poisonous or toxic dyes from water by this range. Okay, this is what we have published in this area. These are the papers which we have published and the work which I have presented. The message which I want, as I said, I have a message I want to deliver. Chemists often collaborate with engineers and environmental scientists to address complex sustainability challenges. So the integral work is the important. What I hope we can do collaborative work, and I think this is a very good opportunity in this conference to deliver such message. We need to be closer. We need to know everybody what the engineer needs and what chemists or what even any scientist can do for this. If we do collaboration, I think we can support the sustainability in terms of such achievements. I mean, in the field of, as I said, examples, corrosion, catalysis, and water treatments, and all of these are existing problems in our community. So, in other words, interdisciplinary collaborations are fruitful. So, thank you for listening. Okay. Any questions? I am ready. Okay. Thank you very much. Thanks a lot. This is my pleasure. This is my pleasure. It is my pleasure to do collaboration with you. Thank you. Thank you so much. Thanks a lot. Thank you.
وايضا سعيده ان اكون بجوار زميلي الاستاذ العزيز الدكتور ومشاركته معنا دوما متواجدين في كافه المحافل العلميه وخير من يمثل التعليم التقني حتى الان ترى كل رئيس وايضا تواجد اخونا الكبير اللي يعتبر قامه من قامات التعليم التقني الدكتور مظفر اللي متواجد ايضا في كل المحافل العلميه. باسمي وباسم كل مكتسبي الجامعه التقنيه الشماليه اقدم لهم كل الثناء والعرفان على هذه الجهود الكبيره لرفع اسم الجامعات التقنيه ليست فقط الاربعه وانما السبعه على صعيد الاقليم كردستان ايضا، واحنا نعمل بالحقيقه كخليه متكامله من اجل اظهار دور التعليم التقني ومنافسه الجامعات الاكاديميه. وبمناسبه هذا المؤتمر اللي يتعلق بالاستدامه احرزت ايضا الجامعات التقنيه يوم امس نتائج متميزه، وكان للجامعه التقنيه الشماليه حصه من هذا التصنيفات بانه بسستينبل التصنيفات اللي تتعلق بالاستدامه حصلنا على مراكز متقدمه من بين 8 جامعات عراقيه فقط كان لها حضور في التصنيف العالمي. فكل الشكر والامتنان لاختياركم مثل هذه المواضيع الفعاله واللي راح يكون لها دور كبير وشأن كبير في رفع سمعه الباحثين والاكاديميين في مجال الاستدامه اللي ترتكز الحقيقه على مفاهيم اساسيه كبيره جدا تساعد في تطوير الجانب البحثي والعلمي. وشكرا كبيرا للجامعه التقنيه وجامعه المستقبل الرائعه المتميزه وجامعه بوليتەکنیک لاقامتهم مثل هذا المؤتمر الرائع. شكرا جزيلا لكم جميعا.
طبعا شكرا جزيلا للاستاذ الدكتور عاصم علاء ولكل المتحدثين في الجلسات المتعاقبه، وشكرا لكل